We finalized the architecture. How do you want to develop this application? Okay, so we assume that we will be having multiple microservices for front end and back end. So this is the architecture very high level that we discussed. Okay, so these many applications we wanted to maintain. So including front end and back end, gateway and one cloud config. Okay, and five different database schemas. Five different database schemas for each service, one database. So which is the data coming from admin front end will sit into admin database. So if admin want to see information, he will see from admin DB only. So for each module, we have a dedicated database also. And for all the configurations stuff, centralized config server also we have. And to give access to the front ends, we have a gateway also, API gateway. Okay, yeah. Now to start with the coding. Okay, to start with the coding, front end or back end. Okay, front end or back end. Somewhere we should maintain this applications code repository. Okay, applications code repository we should maintain. So we need a version controlling tool for that to maintain the code, right? We need a version controlling tool. So to keep our code safe, right? We need it. A repository we need. A repository we need. Okay. We will use Git here, GitHub. Okay. To create our repositories. Repositories purpose is to keep our code safe. If you don't know about repositories, right? Let me tell you what is the main basic use of the repositories is. In case if you don't have repositories, consider olden days when we don't have repositories. Development team used to work on their machines. Let's say if two people are working on one module or one project. Two people are working on one project. One particular module he is implementing and other module he is implementing. Okay, if you imagine old applications, a single repository. So it is struck. Just a minute. Consider me and my friend. We both working on here Ramesh and Suresh, they both working on same project. Okay, they both working on same project. I asked Ramesh to implement admin module, so he is writing admin code here, and I asked Suresh to implement Suresh manager module, so he is working on this code. So only two modules I have for this application. Okay, before they both start working, right, initial application setup I need to do, which means all the configurations, database configuration stuff. They will directly implement use case logic apart from use case front end and back end code. Some configurations related stuff that required. So as an architect, what I did, I created, okay, one basic code which is having connections and all, and all the setup also I have done, all the required dependencies, everything, initial dependencies, everything I added here. So I created some code here. Okay, initial code setup, the basic code I have here, the initial basic code like connections, configuration stuff I have here, so that I created. So before I ask Ramesh or Suresh to work on these modules, I need to provide this basic code. So I'll be giving this code via email or through pen drive. I'll put this it into one pen drive and I need to share it to them. Okay, I need to keep it into somewhere pen drive and I have to share it, or else I need to keep it into CD drive. I need to copy this basic code, and I should ask Ramesh to copy this code and Suresh also to copy this code. Okay, if you don't have any repositories concepts, this is how we people will do, right? If you don't have any repositories kind of stuff, I given basic code so that they can start their module implementation. Admin UI, admin backend, database code, controller code, services code, whatever is required is UI code, backend controller, service, DAOs he can write. Same way he also can write. Okay. Now, end of the day, he completed some tasks here. Like these tasks are for 1 month. 1 month, for 1 month, I given the tasks. Admin module will take 1 month and manager module will take 1 month. So Ramesh spent almost, 20 days to implement admin module. So 80% of, 80% of code he completed. 80% of code he completed, and Suresh also completed 80% of his code in 20 days. Okay. Suddenly, Ramesh mission crashed. Suddenly, Ramesh mission crashed. So all his code would be lost. If some accident, fire accident, something happened, or system crashed. Okay. So system crashed. If system is crashed, okay. I'm telling about the problems. Please, just a minute, please. But last one, the fan finished with it. Thank you. So if his mission is crashed, okay, the problems I will list out here. If I go with this traditional approach, if mission crashed, if any mission crashed, data will erase, data will go on. So if any mission crashed between during his development, right? First thing what we lost is his code. Not only his code, the complete system setup also he will lose. Okay, system setup is anyway he can do it again, but the code whichever he implemented so far, that will be crashed. So what he need to do, Ramesh, again every day, if we think that it is going to happen, there is a chance, right? crashing a machine. So to not fall into this trouble, Ramesh need to take everyday backup into his pen drive. Suresh also need to take everyday backup into pen drive. Okay, every day they should take physical backups. If that physical backup drive gone, if his pen drive gone, yeah, at least code will be there. Okay, so no issues. So they need to take everyday physical backups. To overcome this problem, they need to take. So they should take everyday backup. They should maintain backup in physical drives, maybe in pen drive, example, or somewhere via emails. They should keep this backup somewhere. Okay. Or else, what they can do, they can take one mission access remotely instead of maintaining pen drives, right? They can take one server mission via internal drives access, via drive access. They can even copy this code, and regularly they can update the code also into the server via drive access. Right? In our offices, they used to provide drives access, a central drive. There they used to put common files, so everybody will connect to the drives via run, right? We used to give the drive name here, D drive something, a network drive they will provide, so we can connect via that network drive. So this is also one solution instead of maintaining a physical drive. So even if you have a central server also, sometimes the server also may crash. Your central server also may crash. Somewhere you need to keep one more backup of your code. Somewhere you need to keep one more backup of your code, because at any time your servers may crash, or you may lose your code. Somebody may delete your code. So how you can control this code here? And one more thing, once after done with their code, they should able to run the code with the other modules also. Integration code also they should able to execute. How they will do that integration? So if both done with 100%, then they should commit their code. Ramesh and Suresh both should commit, or both should copy their code in one place. In one project only they should copy. So carefully they should copy. So during development, what they should do, they should follow some standard naming conventions. If Ramesh use some package and some class names, the same classes if Suresh also use same naming conventions. So one developer files may override by other developer also. In case of that scenarios, there may be chances, not maybe, there will be many chances that, let's say, under this basic code which I have given, Ramesh done some updates. So he copied his updates here. Let's say I given a class name A with configurations. So Ramesh added some logic into it. Ramesh updated that class A, but he did not communicated that. He did not communicated to Suresh that A class I updated. So end of the day, I committed my code to server. I copied my code into server. Within the same package, Suresh also need to copy. So when he copy his code, he taken only A class before. So as he don't know that Ramesh is updated that code, he copied his A class also here. Generally it will say, do you want to overwrite the file? So he thought, okay, it's a duplicate class, I need to overwrite. If you overwrite, then code may lose. So override issues you may get. Your code may overwrite. It will not even give you single warning that Ramesh has done some changes. So override problems also may occur. And whenever you want to take code backups, always you need to believe physical drives only. You need to keep physical drives. Physical drives are not at all safe. And there is a chance that any one of these, right, they can copy this code into their personal machines also. If they copy the code into personal machines, all your business will go outside. They may give it to somebody else just to show the code how it is working. or maybe to his friends. They may share the code. If somebody, a competitor, if you see the code, they can easily understand what strategies we have implemented. So you should not. This is not safe actually. Okay, keeping it in a physical drive, nobody will allow. Okay, so if you don't have any other option, this is the only way that we can do. So code is not safe. Maintaining it in physical drives, overriding problems also may you see when both work on the same file, and this is also may happen. You can't maintain histories. Okay, history you may not maintain. History you may not maintain. So what is the problem with your history also? Let's say both worked 100% and they pushed code here and everything is working perfect, and we moved that code to production server. We copied the code to production server. We copied to prod. This code we copied. Whatever code they completed, we copied here. These two modules they're done. Now they started to implement two more modules. Now he picked the customer module, admin module they delivered, okay, and this admin module now deployed into production server, and manager module also deployed, and they started picking new modules, customer and delivery module. Now they started working on this module continuously. They are updating the existing code which is having already admin module and manager module. Continuously they are updating. Let's say now this customer module also reached 20 days, and delivery module also reached 20 days. They are continuously updating their code into central server or pen drive somewhere. Now suddenly this production code is crashed. Production code is crashed, which is working fine with admin module and manager module, which is working with admin module and manager module, and I have not taken any backup. Whatever is there in server also, that code is having new files also now, customer module files and delivery module files. That is also not fully implemented. Some 80% or 50% implemented code not tested yet. That code is there. So when it suddenly crashed, from where I should bring this code? It is crashed, so the code I lost. So at least I wanted to deploy same logic. If I would have taken backup, I can deploy it. But my backup also overridden with new logic. We didn't imagine that there is a crash going to happen. So I overridden that code. So new code is not perfectly tested. New code is not tested properly. So I can't able to move it. So if you don't able to maintain proper history or backups, you can't able to, when there is a crash case, right? You can't able to deploy old versions. Here I deployed this code. At least if I have that code backup, I can able to, you know, again run the same code here, and I can able to deploy it for the production. So as I don't have history or versions, I don't know from where that should bring. Or else some code I deployed here after completion of customer module and delivery module also. All admin manager, customer delivery modules I deployed. I saw problem in customer module and delivery module. I thought of remove this complete code which is having four modules, and I want to go with old code only which is having admin module and manager module. I don't have that history. Already my files are overridden, and my application is updated with the new code. I don't have old code. In case if you think that someday you deployed it, last month 30th I deployed this admin and manager code, and if you have that version here somewhere, if I have maintained it easily, I could able to deploy that here. So though you are maintaining in servers also, during after production deployment, you should have taken a backup. As I don't know that strategy, I haven't taken any backup. So when I see the problem here, then I realized, okay, original code is lost. New code is came here. I don't know what is new code, what is old code. Right? Developers will disturb everything. They go and change every file, and I don't have control also. Somebody did a change, somebody did a mistake from my team. Suresh did some mistake in the code. He committed it. He did, mistake and committed it. And end of the day, both is having the latest code. If I see the problem, to whom I should reach out? I can't able to ask Suresh or Ramesh who done that mistake because I don't know who updated that code. So who updated, when updated also I can't able to see. Okay, by whom the code is updated. So reviews problem also will happen. So during the review, right, may not able to identify who committed the code, who committed, who committed that code, and when committed that, who and when committed the code. You can't able to trace it out. So developers may continuously do the mistakes and they may throw that mistakes on somebody else. Okay. So there will be many problems if you go with the physical drives. So there the version controlling tools came into the picture. There the version controlling tools came into the picture. So like SVN, Bitbucket, Git you can use, VSS. There are many version controlling tools. So these version controlling tools, how they will help? If you take Bitbucket as an example, Bitbucket is a some cloud based repository, or Git is a cloud based repository. GitHub, they are cloud based repositories, means they will be available via web. They will be available via web. So as a company, if you registered or if you buy the version control tool, let's say if I buy for the Arbutech a dedicated URL, they will provide to access my Git. Dedicated memory also they will provide to me. A dedicated Git memory they will provide to me, and when I put my code into the Git, it will take care of backups. So when I put one code repository into the Git, internally they will maintain so many backups. When it crashed, when their website or Git crashed also, they will bring backups. So they will maintain so much backup internally, backup techniques, and they will keep our code always safe. And they don't allow everybody to access your code. There will be some privileges also to your code. Let's say if you don't want to give privilege to Ramesh or Suresh to delete the logic here, they can copy the logic, they can paste the logic, but they can't able to delete the logic. If it is a simple file system, they may crash. But in Git, you can control. Privileges also we can provide. So privileges support also we need for any repository. Yes. Yeah. Is it fan sound for everyone? Getting Are you getting a lot of noise? So how is it now? Is it good or just a minute? Mic is catching fan sound. Is it better now? Yeah. No. So we can't control the users, and we don't know who committed and when committed. We don't know the versions. If some days back, if I deployed the code, if I want to go there and find my code, I can't get it. And code override issues you will be seeing. Okay, and code backups, maintenance of code backups also a difficult task. Every day one person need to be assigned to take that backups. And virtual reviews also not possible when you go with physical drives. Virtual reviews. So after you commit the code, if your code is good or bad, if I want to comment it, physically we need to note that changes, and again you need to work on it. So actually we can't maintain the reviews also. And approve or decline, to approve or decline you don't have any control, just you need to say team do that changes and again copy it. But when you go with this repositories, they will ensure all these problems, they will resolve all these issues. Since maintaining from your code backups to maintaining versions, privileges control, and who committed and when committed, you can do reviews. Once after reviews you can do approves or declines also, so that they can't proceed their code for the next level. So the same thing, instead of maintaining via a physical pen drives and all, how I can maintain when I choose a version controlling tool? As a architect or as a senior guy, I can implement some basic code, basic skeleton of the project. Okay. So the skeleton of the project I can create here, and I can keep this code into Git or Bitbucket. I can keep my code into Bitbucket. This basic logic I can put here. In Bitbucket, we call it as we create repository. Okay. In Bitbucket, you can create your repository. You can create a repository for your project. So within that repository, I can put my code. Maybe you can name it something like main. This is the first skeleton that I need to create and store it here. Now, if any developer wants to continue further, what they have to do, they should, let's say Ramesh now, if you want to work, now he will not directly copy your code or he will not download it. Using Git tool, he can get this code, still he will not work on the direct branch. So we will put certain rules or standards how you can work here. When you want to work on admin module, and Ramesh wants to work on admin module, we will ask him to create a separate branch. I'll say don't disturb my code. You may disturb when he pull this code, and if you do some changes on my code and if he commit it, my code may disturb. So what I'll say to him, though still I can see versions and all, still to keep a control on this main repository. Consider main is the golden repository for me. So I don't want to allow anybody directly to pull the code here. So I'll keep a control on this. I can put control here. So I'll put control on this. So nobody can commit their code directly. Okay. Nobody merge directly until unless I approve it. So what he need to do, as he can't able to do it, he can able to create a branch. This code he can able to copy into a new branch. He can create one more new branch here, saying admin branch. This code parent branch is main. From main he can cut this branch. From this branch he can cut it, so that whatever code I have committed, right, A, B, C, whatever classes I have given in this main branch, he will get that code here into this branch whenever he creates. Now what he can do, he can pull that code here. He can pull that code here. And he can work daily. He can work at the end of the day. Today he started working. So he implemented something here for admin module UI implemented. So he implemented some part of UI, 10% implemented. What he can do, end of the day, while closing his mission, end of the day, he need to commit his code here. He need to push code here, so that in case if his local machine gets crashed, also his code will be safe here. Daily, he need to do that. I mean, as a developer, we need to have that practice, as it is your branch and it is your responsibility to commit your code daily here. You should not come and say my machine is crashed and I lost the code. How your code will lose if you take backup here. So daily it's your responsibility to keep your backups here. So you need to pull your code here, right? You need to pull your code here first. End of the day, you need to commit your code on daily basis. You need to do it. As a lead, you need to instruct your team in such a way, whatever you have done changes, small change or big change, commit it on daily basis here. They should commit it so that their code will be safe here. And we can have a watch also. As a lead or as a scrum master, I can go and see what he is doing. Is he really adding any value, or he is just spending time without doing any changes? So I can able to see daily progress also here. Is he spending his 6 hours of time or 5 hours of time properly or not? If I see anything wrong, I can immediately reach out to him and ask, do you have any problems? Yeah, generally developers will do the commits in case if they have any changes. If they don't have changes, if they are still doing something analysis work or paperwork, if he's doing, he may not do any commits. But if he start doing the coding, it's his responsibility daily to keep code safe into this branch. So once you commit your code here, your code will not go anywhere. It will be safe. So now I thought that my code is perfect. I implemented 100%, and I tested in my local also. This model is working fine. Then completely I can commit my code here, and I can raise a review request. Okay, I can raise a review request to this branch. So we call it as peer review. So this review, during review request, right, he can add me to the review, my email ID or something, my name. When he add for the review, I'll receive a immediate email that he wants to do the review. So in a call, Ramesh you know, can make a call to me and he can ask me to review this code. Or he can ask his co-developers also. Peer reviews anybody can do. Let's say there is one more senior developer, Suresh is there, then he can ask Suresh to review his code. You can ask him to review his code. So he can add Suresh name to review. So both are working, they should review themselves. Or they can ask a review from their team lead. It's everybody, responsibility to the review. If they are free, or they need to free themselves and they should review it along with their regular duties. So if you raise a PR request by adding Naveen and Suresh, they both will notify saying that code is there for the review. Now what he can do, he can go to Bitbucket. When he click on so and so link, it will take him to Bitbucket. There it will show changes. Whenever he do the changes or add new files, right, Bitbucket will bold that files and it will show that Ramesh added so and so files. He added some UI related code. History clearly it will show which files he edited. Even if you do edits on the file A also, that clearly will show with by highlighting with colors also. If you delete something, that will show it in a red color. Immediately I can ask why you deleted that. If you delete entire file itself, it will show here the file got deleted. If you do some updates or if you add some additional logic also, it will show it in green. I can ask why you added that additional logic. Or if you add any new files, what we can do, in call everybody can connect, maybe in screen sharing, or if they don't want to do in call, personally if they want to review also, they can review. So they can go to each and every file and they can review the code. They can see whether he implemented with the good standards or not. If there are any comments, if they want to add, they can add comments also here. They can add comments. They can add comments. They can add comments to the code. Right? Suresh wants to review it. He can add his comments. And Naveen also did the review. He also can add his comments. Both can add their comments for that particular PR. Both can add comments. Now, what you can do, you can decline. After review is done, you can decline further merging it to main. Decline means cancel that PR. You can cancel that. Once PR is done, basically if you have only main, I mean two branches only, it will ask you to merge if you have only that privileges. Now we only have the privileges, okay, along with PR. After PR, right, Ramesh can ask for merge request also, MR also he can raise. He can raise MR. If PR is good, he can raise MR merge request. So if I approve, this code will sit into main branch. The entire code will push to main branch. In the PR itself, if you decline it, then he will be notified by saying that so and so comments Naveen added, so and so comments Suresh added. Please work on that. So again, he will do necessary changes. He will again do commit his code with a new PR request. Again, both will review. If they see everything is fine, they will approve this PR. The PR will be approved. As soon as PR is approved, now it is good to commit to the main branch. So what you can do, you can raise merge request. So again there I can take decision whether it need to merge it immediately or not. If I don't want to merge it, let's say here I have some code which is working. I want to do the merge only after Suresh code. After Ramesh done, I wanted to wait still for the Suresh code also. So you can wait. You can say to Ramesh, wait. After getting Suresh code also, I can merge it at a time. Maybe the reason is once getting everybody's code here, this branch I may take and I can test it. This branch I may take and test it, or I may deploy into the testing server and I can ask testing team to work on this. I can push this to testing team. So if testing team done with their testing and if they say, okay sir, everything is good, you can merge it. Then I can merge it. Okay, it's up to you. Sometimes we don't merge until unless everybody's code is done. Because all the integrated code only I wanted to take it to next stream so that whatever code is there in the main always I will consider it as a working product. So if that is the rule, if I put only working product only, I will take it here. So everybody need to done with their development and they should push their code here. Maybe Suresh will not work on this branch. He may work on a different branch. Like he working on the admin branch, he may work on the different branch. So how to maintain these branches? How many branches we can create like this? Generally, what I used to recommend is once I create a skeleton, right? Skeleton or initial code, basic code I will add into a main branch. Okay. From this main branch, I used to create one more branch called production branch. Okay. Any number of branches you can create. So whatever basic code you have implemented, that code I want to take it into production branch and UAT branch, and I'll be creating one testing branch. Okay, so I'll keep the same code into these three branches. Main is the first branch, then I'll keep one same code into prod branch, UAT, and testing branch also. Now when I ask a team to work, right, team can cut the code from main branch, or else you can create, let's say sprints wise my development is going on in many iterations. Sprint one module or one feature is people is working. In sprint 2 they are working on a different module. So like that, if they have multiple modules they are working in a iteration. So for each sprint I may ask them to create a new branch for each sprint. Okay, just name it sprint. So each sprint I may ask to create a new branch. So I may create one branch. Let's say people are working on sprint 1 branch. From main, I'll get the code into sprint 1 branch. And I'll ask people to create their sub branches from this sprint branch. Let's say if 5 people are working, let's say one is working on feature 1, I'll ask him to create one feature 1 branch. For other person, feature 2 branch, feature 3 branch, feature 4 branch. Each individual can create a new branch and they can work on it. Let's say 10 team members are there, they can create 10 branches. Any number of branches they can create. Or let's say if you don't want to do it from the main, so during commits, right, we go this way. Once after develop testing is done, integration environment also we will be having integration SIT, or you may say dev test branch, you may call it as SIT. Dev branch is a integration branch. Everybody's code should come to dev branch first before testing branch. So first initial basic code I'll put it into every branch. So the main parent for all these branches is main, then prod, UAT, test, and dev. So I will ask the team to create a sprint branch from dev. Okay. So from dev, a sprint branch is created. Everywhere you will be having same code, basic code, whatever you implemented. Let's say you have two classes AB. AB code only you will be having in main branch, prod, UAT, test, dev, and sprint. Now when I ask people to create child branches, they will get that same code into child branches, AB classes. So now people will work on these branches in their local machines. As soon as they're done with their development, right, they will commit their code from their local machines to their feature branches. So here developer 1, if he is working on the feature 1, he will commit his code. So as soon as he done, right, first he will pull this code, then finally he will commit his code, right? Daily he do this job. He daily get the new code and he will commit it. Full commit everybody do. So once he feels that his code is good, he need to raise review request. So he will raise a review request to sprint. So everybody will review it. Once PR is done, he will raise the merge request. Then code will be merged to sprint. And there itself, his job is not done. Once he committed code to sprint, okay, he should ensure that his code need to be merged into dev server also integration. He need to check, he need to run his code into integration environment also. Let's say his feature is not having dependency of feature 2, feature 3, feature 4, feature 5. His code is independent to work. Let's say he implemented one screen, that screen related controller, service, DAOs, everything implemented. He wanted to run it in dev server. So what you need to do once after moving it to the sprint one, from here you need to move his code to dev branch. It is his responsibility. So again he need to rise. Once PR is done means his code is reviewed. His code is reviewed. So he may raise merge request only here. He may raise merge request from this sprint branch to dev branch. Then that is approved. His code is available in dev. Maybe if we have any CI/CD support, right? From these branches itself, from this Git or Bitbucket itself, we can deploy this code also into server. So usually we will have one integration test environment, dev environment. So dev server we will be having dev server. When he commit his code here and he can raise a request to deploy his code into dev server. Maybe using Jenkins kind of stuff. Jenkins as a tool for deploying, right? He can move his code, dev code to dev server by the support of Jenkins. So Jenkins will provide you one trigger file here. As a developer, I need to go that trigger file and I need to do some changes on it. So immediately Jenkins will listen that trigger and they will build your code. Jenkins is a combination of all the tools. Maven, everything will be integrated. Or what it will do, it will, yeah, maybe it will do all the packaging, everything, and it will deploy your code into dev server, final code. So as a developer, what you can do, you can test your code is fine working in dev or not. Okay, similar way, everybody is done with their sprint. Okay, everybody done with their sprint. So the sprint one is having all the features which are given for the sprint. Feature 1, 2, 3, 4, 5. These 5 features are completed by these 5 developers and they committed it. And all the reviews happened, merges also happened. Everybody need to raise merge request to dev. So from here, everybody can do their deployment. So I came first, so I can do my deployment and I can test it. And I may inform to my team my code is deployed. Or before deploying my code, I may warn my team people via email. I am deploying my feature one to test, so that everybody will aware that you are working on it, so they don't disturb your testing. Via email you may inform them. So if others wants to also want to deploy it, they may reach out to you whether they can able to deploy it now or not. Or once after you're done with your testing, you may say I'm done with my testing, others can proceed. So others also can push their code here and they can trigger the deployment. So the latest code always, as soon as they commit their code here, right, so the latest code will be having into this dev branch. So when you trigger that deployment file, the code will move to dev server and they can open this dev server URL and they can test it. and everything is done. As a lead, I believe that everybody done with their, or a lead or a senior developer, you can take decision. Everybody done with their code and it is working fine. So immediately you can do what, you can raise one more merge request. You can raise merge request to test environment. As soon as you merge to the test environment, here also you will be having a trigger file. So when you do changes on the trigger file in test environment, your code will be deployed into test server. So testers will work on that server. So if you have a test server, so that in Jenkins we do configure each server, access. So the Jenkins will do what? It will do build on this test branch, and it will move your code to test server. So the people who is working on the testing, they can access this test server at URL. Now testing also done. Now I thought to move it to UAT, user acceptance testing. Here customer will test your code. In UAT branch, customer will test your code. Customer means your client. Client also need to test before production to ensure your code is working fine or not. So then again Jenkins will deploy it into UAT server. You will be having for each environment a dedicated server, or at least a server you will be having. So this code will be deployed here, and UAT also will be testing. Users also will test your code. User acceptance testing. Once they say code is working fine, then again we will be raising merge request to prod. So how many merge requests overall here? Feature to sprint 1 merge, sprint to dev 1 merge, dev to test again merge, test to UAT again merge request, and UAT to prod also you can raise merge request. Now production is deployed. I want to take backup of it. So you may move this code to main. So main you can consider as a golden repository. So in case if you want to backups, maybe you can visit your main, because whatever production deployed code that is available in main always. If somebody wants to see what is the production code, instead of giving access of this prod, from main you may create one more branch and you can give access to others. A golden repository we say. This is the golden repository which is working perfect. Okay, this is how we do merge request, and each merge request need to be approved by a dedicated person who is having the control on this. Maybe your technical lead will have that control, or a senior developer, or if you are the person to take care of this merge, you need to take care of it. As a developer, it's your responsibility to take up to UAT environment. After UAT, we will get some production dates, approvals. On that production day, we will merge our code and we will trigger that file so that your code will be deployed into prod server. This prod code will be used by end customers. End customers will access this production, and here also your code will be deployed via Jenkins, and this code you can access it. A simple architecture I'm saying. Okay, so this is how you need to maintain branching strategy. This is how you need to maintain branching strategy. Okay, so first to create a main and put the skeleton. If you are working on a brand new project, if you choose any existing project, they will maintain such branches. Okay, from main to cut one production branch, prod to cut one UAT, UAT to test to dev, then dev to ask people to cut their sprint branches. Maybe if you are working right, you should having or knowing all these strategies, right? You must aware of all these branching strategies. Okay, so this many repositories we need to create now. We have Zira access. If they give us free Bitbucket access also, we will create branches. What I will do, the branches we will create it on next session, tomorrow session. Okay, I'll create branches and we will put this skeleton here. From that branch, we will, start coding it. Okay, na? So this is also very, very important. Am I making any sense, or many people don't know the strategies? My colleagues, right? Which project? Yeah, current project on. They started creating main branch and people started working on it. Yeah, current project only. Current project and previous one also. Okay, so this is very important. If team is not aware, right, you explain them the importance of it. So the same discussion I had with my team, then they started creating this many branches. And initially I say they definitely will see problems. They were saying why the code will be available in main now. How I will see the problems. They were arguing it. Then I told them how you will control it. So now clearly we have branches for each stage. People will not suddenly put the code here and deploy it. Let's say if you have only one branch, people will commit here and they do a lot of nonsense. But if you have stage by stage, they need to commit to sprint branch, then they should commit to dev branch, they should verify it. If they see any integration testing issues, they should again come back to their code and they should rectify that problems. Then again they should raise PRMR and they should resolve it. Until unless they complete with this integration testing, as a lead, I don't even allow them to move their code to test so that I can have control on the code. If someday if manager comes and asks why the not working code there in test and UAT, you should answer it. So if you maintain these strategies, then you can ensure it. You can sleep, confidently during nights. Otherwise, you will be worrying always what he is doing. He is committing. He will create any new issues tomorrow. Maybe they don't do it intentionally. They thought they might working it properly and they may move it without testing. Or maybe there are some cases they may forget to test. So once we ensure that everything is working, if you can able to allow them to move to next branches, we will be having a control on the code. So the same strategy we follow for our application, we will be creating it. So before going to creating branches, I will check if I have Bitbucket access, right? I will see definitely they provide. I'll create a project in Bitbucket and I'll show you from project how to create project, how to give access to people like Zira. Okay, so that you will be having end-to-end knowledge on the branchings as well. Then we will see how to pull, how to commit, how to do reviews, merges, if there are any merge conflicts, how to resolve them. As I was discussing, right, same file can touch by many developers sometimes. So when they do that, there will be chances you get so many merge conflicts. I do changes on the file A for feature 2 also whoever is working. He also done some changes on A file. So during merging, right, I'll get conflicts here. It will say you have conflicts, you need to resolve them. So whoever commits first, right, they are safe in such scenarios. Always what I used to do, either I will commit first or last. As a developer, I will commit first or at the last. I will see if anybody committed here or not. If nobody committed, right, I will do my code fast and I'll commit it here. Or else, whoever commits first and whoever doing next, right, they will see all the merge conflicts. They need to pull again latest code. They need to resolve all the issues. Then they should merge it. Again, that is headache for the next developer who is doing it. So what I will do, I'll do either first or last. But you don't follow the same strategy. As soon as you need, get the latest code, resolve the conflicts, and merge it. We will see such scenarios also. Okay. Yeah. So for today, I'm done. Uh, Tomorrow we will create the branches, and map and we will discuss maybe Monday session. Okay. I want to take some lengthy session on it. Artifactory also I want to try private artifactories. So to do that, I need time till Monday.